Example number 28. Determine the interval over which the function is continuous. Here we have a square root. The radicand, which is the expression within the square root, must be greater than or equal to 0 to be continuous. If we solve this for x by adding 7 first, we get 4x is greater than or equal to 7. Divide by 4. So x is greater than or equal to 7/4. Therefore, this function is continuous everywhere from 7/4 to the right to infinity. So in interval notation, it's bracket 7/4 infinity parentheses. We need to include the 7/4 because that's the value that will actually make it 0, which is fine because the square root of 0 is in fact 0, and that's a real number. So we include the 7/4, everything to the right, and on our interval notation we use parentheses always with infinity or negative infinity. Example 29. Graph the given function, find all values of x where the function is discontinuous, and find the limit from the left and right at any values of x where the function is discontinuous. So here we have a piecewise defined function where if we pick values that are less than 0, we have to put them into 3x plus 8. And if we pick values greater than 0, we have to put them into x squared minus 3x plus 8. And if we actually pick 0, it goes in the first one. So anything less than or equal to 0 goes there. So this is a line, okay, a linear equation. And I know that because x is to the first power. And this is a parabola or a quadratic equation. And I know that because x is to the second power. So a line with a positive slope is going to go up, and a quadratic with a positive leading coefficient is going to be a U-shape up. So it's going to be some combination of a U-shape and a straight line. The answer may or may not have printed properly here, so let's just go ahead and just draw the graph from scratch. I'm going to pick some values that are less than 0, like maybe -3, -2, -1, and I have to also look at 0, and 0 is included on this portion of the graph. So these are my input values, and these are my h of x values. So using substitution, 3 times -3 plus 8 will be -1. 3 times -2 plus 8 will be -6 plus 8 is +2. 3 times -1 plus 8 is -3 plus 8 is 5. And 3 times 0 plus 8 is going to be 8. So now I'm going to plot these points, and I'm going to try to do it to scale. Be better if I had graph paper, but you'll get the idea. So -3 is at -1. -2, it's at 2, so I got to go up to 2. -1, it's at 5. 2, 3, 4, 5. And at 0, it's up here at 8. So this is going to be a straight line that continues this way, but it stops at 0 where it's at 8. Now I have to look at the quadratic side. That's the U-shaped side. And I have to pick some values. Where x is larger than 0, but I need to start with 0 and remember to put an open circle because it's going to go right up next to 0 like 0.00001. So I'll put an open circle at the value at 0, and therefore I know that I'm not including it by putting an open circle. Then I'm going to pick some other things bigger than that, and I just need to do a couple. So I'll go 0, 1, 2, 3. I'm going to move this where I have a little better space. Then I'm going to enter my y, or my h of x value, 0 squared minus 3 times 0 plus 8. So at 0, 8, it's actually here, so I don't need to put an open circle because there's already a point there. So there's not going to be a discontinuity at this exchange, which there often is. Then I'm going to do 1 squared minus 3 times 1 plus 8. That's 1 minus 3 plus 8. That's a 6. So it's dropped down to 6. Then I'll do a 2. 2 squared minus 3 times 2 plus 8. That's a 4 minus 6 plus 8. That's also at 6. So it's a U shape, so it goes down and it comes back up. 3 squared minus 3 times 3 plus 8 is going to be 8. And so now it's back up here at 8, and it turns around and it goes like that. So looking at these possibilities for graphs, and there's 3 showing on my paper, and the correct one is not here. Look, this one has the parabola. A has the parabola on the wrong side. So does B. And C's not right because there's an open circle there. But remember, when we did this side, at 0, there's a closed circle because it's included there. So the correct answer is going to be D, our answer, or I'll color that in and we'll call that graph D. So in part B, we should select where the function is discontinuous. But remember, when we did the second part, we ended up back at the exact same place as where the first part of the function left off, and we don't have any discontinuities because I could draw this graph without picking up my pencil. So there are no discontinuous values, so the function is continuous everywhere. And so part B down here, and so part C, also there are no discontinuities found in part B. So we don't have to look at the limit from the left and right because, as we said, it's coming in from the left and the right to the same place, which makes it continuous.